Hi, I'm Fred Lange. In May of 2008, I was near Quinter, Kansas with a commercial storm chasing tour from stormchasing.com. The tour guide had positioned us almost perfectly, so we got to witness the complete evolution of an EF4 tornado from its origins as a puffy cumulus cloud through becoming a severe thunderstorm, then developing a wall cloud, and then producing a funnel with touchdown. It was quite an event, and I have a number of photos here I can show you that illustrate the day. We started the day near Dighton, Kansas. We waited in a field and observed a number of very ordinary cumulus clouds building. There was a fairly substantial cap early in the day which prevented towers from forming, prevented the clouds from lifting high into the atmosphere. But as the day wore on, some small towers, such as the one you see near the middle of this photo, began to appear. This is the group. We had 3 SUVs and a total of 17 people. This is also looking in the direction of the denser cumulus that would ultimately go on to spawn the Quinter tornado. In fact, within just a few minutes of taking this photo, we were in the SUVs and heading towards the storm. You can see this is shot out the window of a moving SUV. The cumulus very rapidly building. And look down towards the horizon. You see how dark the cloud has already become. This is just in a matter of minutes. The storm was almost exploding before our eyes. Another shot of the rapidly building cumulus. And the rain clouds we could see ahead. This is within, perhaps 20 minutes of leaving the field where you saw the group photo. Very, very soon, the anvil began to form. The tower rose about as high as it could without mushrooming, and then did begin to explode like a classic mushroom cloud. And here you can see the edge, the lower edge of that cloud as it's ballooning outward. Spectacular sight. Here we're in the SUV and heading forward. You can see off in the distance the dust of the lead SUV. This shot was taken from the second SUV with the third one on the highway behind us. Each of the vehicles had a laptop that was connected to a server actually operated in the lead vehicle. The lead vehicle was sharing an always-on cell phone connection so that each of the chase vehicles had access to the internet and access to near real-time, highly detailed radar images. This allowed the tour leader to position us with some precision. Here we're barreling down these roads. We're doing 60 and 70 miles an hour down these dusty farm roads. As we got closer, the clouds got darker. And here we could identify the center of the uplift. That's not a funnel that you see in the middle. There was very little rotation and very little movement at all in these clouds. That's just a condensation trail from where the enormous updraft is pulling surface air up into the center of what is this enormous thundercloud over our heads. This is a little contrast enhanced to bring out some of the details. On the left you can see the virga, where some of the rain is falling from the trailing edge of the storm. Most of the rain in a thunderstorm of this sort actually is towards the leading edge of the storm. And in the middle you can see that strong updraft I mentioned previously, and that's going to be where the wall cloud forms. And this is without the enhanced contrast. This is what it looked like to the naked eye. As the storm was moving away from us, we only watched for a few minutes and then got back in the SUVs and made haste to get closer to the storm while keeping an eye on the near real-time radar images. We used the radar to position ourselves near what was a developing bulge in the middle of the storm. You can see it in the radar screen. This is where our tour leader thought the classic tornado hook would form. That rotation would build, or actually was already beginning to build there, and that if there was going to be a tornado from this storm, that's where it would appear. You get an idea now of how that updraft cloud is beginning to thicken and almost solidify. As we approached the center of the updraft, the clouds got thicker and lower. You have to remember that a thunderstorm is basically like a chimney without walls. It's a column of rising air, and as the air, moist air, rises, it releases its latent heat, the heat of condensation, which keeps the air inside the tower warmer than the surrounding air and continues the uplift. So it fuels itself with the air that's being drawn in and creates an ongoing and intensifying uplift as the storm builds. The center of the storm is actually at lower pressure than the area outside the storm because of this uplift going on. And one of the effects that happens when warm, moist air is drawn into a region of lower pressure, the water vapor in there can condense. And that's what you begin to see in this photo on the right-hand side. What had been the condensation trail cloud going into the middle of the storm has become a lowered area. This is as the low pressure intensifies, the water vapor in the incoming air is condensed at ever lower altitudes, and you get this lowering effect. This is actually the beginning of the formation of the wall cloud. And here you can actually see, this is just a couple minutes later, you can see the wall cloud beginning to take shape very clearly. However, I'm also realizing that I'm approaching the end of the length limits that the public video hosting sites impose. So I'll stop part 1 here, and we'll pick this up in part 2.